Okay, we're going to start with a simple example. We want the distance between the vector v and the vector w. Now, I've already told you that the vector distance between two vectors can be pictured like this. Just you put the two vectors with their initial points at the same point, and then it's just how far it is from here to here. And this applies in any Euclidean real space. So we want to start by sketching. So if you weren't in class, even if you were, you should quickly sketch these two vectors. Sketch similar to that one, but the vectors aren't going to be in those directions because, of course, these are different vectors. You should pause and do that, and you should have paused and done that. You should not have gone on until you drew these. Okay? I assume that you did. So let's say this is your vector v equals 2I minus 3j. 2 units this way, 3 units this way. And then the other one is in a not parallel direction, but a very similar direction, is w equals 4I minus 5j. Okay? So that's what your sketch should look like. Okay, now, figure out the distance from here to here. Okay? Now, you can do that. This is in R2. You could sketch a right triangle, or you could do something else. So in any way you can think of, sketch the distance between these two and figure out what that distance is. Okay, well, I assume you've done that. If you haven't, do it. Don't just sit here as a spectator. You won't learn much. Yeah, maybe, if your IQ's high enough. Okay. And if you haven't written it down, at least have it in your head. You should be able to calculate that distance in your head very easily. Okay, well, the distance is just this distance here. So one way to find that distance is, well, if this is the origin, so let's just assume that this common point is your origin, which is kind of the traditional way to represent vectors in a Euclidean space, an n-dimensional Euclidean space, in this case 2-dimensional. Then the tip of this vector will be at the point 2, negative 3, and the tip of this vector will be at the point 4, negative 5, so that if you look at the rise and run between these points, you're going to see that this is negative 2 and this is 2 if you go from this point to this point. So distance is the hypotenuse of a triangle, one of whose sides is negative 2, the other is 2, and really the sides just have lengths of 2, but I'll write it out. It's negative 2 squared plus 2 squared equals the square root of 8, which is 2 square root of 2, and hopefully you would have written that down. If you didn't, think about why you didn't think about it. Okay, or you could have done that in your head. Many people can, not everybody. Okay, that's one way to do it. Now, another way to have done it, and where did my purple chalk go? I want to use purple chalk here. Another way to have done it would have been to sketch these two vectors. And noted that a vector from here to here is w minus v. So, what's your distance then? Okay, how would you get your distance if you know w minus v? Well, I'm going to say, let's hold off on that for a minute. Okay, I'm going to make a definition. First of all, I'm going to say that your distance, well, I'm going to define length. Well, what would the length of this vector be? Well, this vector goes 2 units this way and 2 units this way, right? So its length is just, again, the square root of 8, 2 times the square root of 2. I'm going to define the length of the vector, though. And we'll just call it the length of a vector u. The length of vector u, first of all, we denote that by some absolute value signs with attitude, called the magnitude of u. It's also the symbol for a norm, and we might talk a little bit about norms. Easily understood if you understand the linear algebra. Okay? Well, let's see. I'm going to start just by talking about u dot u. Now, this isn't quite the definition, but let's just take an example, okay? Let u be the vector 3i plus 5j. Okay? Then what's u dot u? Well, if we use our row-column definition of the dot product, the one we've been using, we make u a row vector. That would be 3, 5. And then we make u a column vector. Clearly, the row times the column gives us this, which is 34. Now, the length of u, well, it's 3 units in this direction, 5 units in this direction, right? So 3 squared plus 5 squared, well, we've just done that, haven't we? Okay, 3 squared plus 5 squared is 34, and the length, of course, by the Pythagorean theorem, is the square root of 34. Length is square root of 3 squared plus 5 squared by the Pythagorean theorem. So this motivates the definition that I'm going to complete here, which is that it's not u dot u, because u dot u in this example gives you 34, right? It's the square root of u dot u. So there's your definition of length. So just as a quick exercise, figure out the length of the v vector that we defined up here. Okay? You should have stopped and done that, or done it in your head. Now, we can say that, that we could have a right triangle that goes 2 units here and 3 units here. So the legs would be 2 and 3, and the hypotenuse would be square root of 2 squared plus 3 squared. Okay? And that's what? Square root of 13. Well, I'm going to use the definition. Okay? Now, just see if that agrees with what the Pythagorean theorem gives us here. Length, magnitude of v, using the definition. If you haven't written this out in terms of the definition, do it. You really have to get used to doing this in order to get in the habit that's going to allow you to do proofs. And it's important to do proofs because if you're trying to think through a complex problem and you want to write down a step and you're not sure that step's right, you got to go back and kind of prove that step in your head, so you don't have to go look it up. And if you don't have all this stuff in your head and the experience of writing proofs and the experience of working things out this way, you're not going to have it. Okay? You're going to take way too long to do it. You're not going to know it well enough. You're going to lose track of what you're thinking about, and you're not going to come up with the kind of conclusion that leads you to the results that you really need in your life and in your profession. Okay. So anyhow, how do you get this magnitude of v? Pythagorean theorem tells you it's a square root of 13. If I did my arithmetic right, and you want to check me on that, well, it tells you it's the square root of v dot v. And that's what? The square root of, well, v is a vector 2, negative 3. So if I write this as a row, 2, negative 3, and then as a column, same vector, that comes out square root of 13, and the calculations are trivial. 2 times 2 is 4, negative 3 times negative 3 is 9, add them up, you get 13. Okay? So that's definition of length. Now we'll continue.